This is the screencast for section 9.4, example 2. We're going to look at a sequence again, but this time recursively defined. So a recursively defined sequence specifies values for the first term of a sequence, then it defines each of the following by a formula relating it to previous terms. So for example 2, we're supposed to find the 6 terms and the 100th term for the sequence defined recursively by the conditions b1 equals 3, and then after that, any item in the sequence is defined by adding 2 to the previous entry. So b1 equals 3, that means b2 is going to equal b1 plus 2. So in this case that would be 3 plus 2, which is 5. Well then, b3 would be b sub 3 minus 1, so b2 plus 2, which would be 5 plus 2, or 7. And we can follow that pattern all the way through the first 6 entries easily. And now the challenge will be finding the 100th term in this sequence, because I don't know about you, but I don't want to do 100 of these. So I kind of have to look at the pattern more in an explicit way. Well, if I start out with 3, each entry after B1 is adding a number of 2's. So I can look at this as 3 plus and then n minus 1 2's. So to find the 100th term, that would be 3 plus 99 2's, which is 201. The now try problem number 5 asks us to find the first 4 terms and the 8th term of the recursively defined sequence. A sub 1 has already defined as to equal 8, so a sub 2 is going to be a sub 1 minus 4, which in this case will be 8 minus 4, which is 4. A sub 3 then will be a sub 2 minus 4, so in this case 4 minus 4, which is 0. And I can continue on actually finding the first 8 terms. That might not be too bad, but I'm just going to find the 4th and then look at the explicit pattern to find my 8th term. I start out with a sub 1 and I n minus 1 4's depending on which term I'm looking at. So in the 8th term I'm going to subtract 7 4's, which will leave me with a negative 20 as that term.